Hi guys, today I'm going to show you how the data, right, is going to be encapsulated when you browse google.com on the PC1. Okay, let me open up PC1 because PC1 is has an IP address of this and subnet and default gateway and DNS server is 10.10.10, right? And PC1 also has a MAC address on the Ethernet 0. Okay, so let me type google.com and let's see what is going to happen on each of the network device, right? We are going to capture the packet and open it up and see how it's being constructed, right? Okay, and google.com, go, okay. See, you see a message here, right? What is this message? Let's see. Okay. This message is going out. First of all, it started on the PC, right? And then it's a DNS layer 7, right? Obviously, this is layer 7, layer 6, 5, and 4 is TCP UDP layer. And then layer 3 is IP layer, layer 2 is MAC layer, layer 1 is the fast Ethernet 0. Okay, let's see. Because the first message looks like it's a DNS query message, right? The DNS client sends a DNS query to the DNS server. Why? Because when you type google.com, right, the PC need to know google.com's IP address. In order to know the IP address, the PC will send a DNS query message to the DNS server, right? So that the DNS server can return google.com's IP, okay? Remember, the DNS server's IP is 10.10.10.10, right? I already configured it on the PC1, okay? So the PC will send out this message, like layer 4, you can see that's the UDP source port is 1026, right? And destination port is 53. So the DNS server is listening on 53 because port 53 already assigned to the DNS service on the server. Okay, DNS application on the server. Okay, then you see layer 3 header. Layer 3 header is a source IP and destination IP, right? Source IP is the PC's IP, destination IP is the configured DNS server IP, okay? Then layer 2, you can see is the source MAC address, destination MAC address, right? Destination MAC address is not the DNS server's MAC address. Actually, it is this router's, this port MAC address. Because as you can see, it's only need to add this next hop MAC address, right? Okay, let's move forward. We can capture the packet. Okay, now the packet is forwarded out, right? Because it's constructed all the way from layer 7 to layer 4, 3, 2, and everything is known, right? Then it can send out. Then let's open up this message. Okay, if you open up this message, you can see there is a coming in and going out, right? Coming in from fast Ethernet 0/1, going out from fast Ethernet 0/4. That's layer 1. Okay, then layer 2. As you can see, layer 2 is shown here as still source MAC address, destination MAC address. It didn't change, right? Source MAC address is the PC's MAC address, and destination MAC address is this router's, this port MAC address, right? It's going out still, right? The same. So that means the switch, look at that. The switch doesn't check anything like over layer 2, right? It only checks layer 2 and no layer 2 and layer 1, okay? Let's move forward. Okay, the packet is sent out from this port and arrive at the router 1, right? Let's open this up. You can see the router looks like router has more layer checked, right? It checked layer 2, layer 3, and layer 1, right? Both. Let's see layer 2, right? So the incoming packet, this router packet, right, is the source MAC address, destination MAC address didn't change from here, right? It didn't change, but outgoing, right? The outgoing port is Ethernet 0/1, right? It's this port, okay? Incoming port, outgoing port. When it is outgoing the router, see that? The layer 2 MAC address changed. Rewrite. Why? Because MAC address only work in layer 2. If it's go to another hop, this is one layer 2, another layer 2, right? This whole segment is the layer 2, right? These two connections are layer 2, right? If the packet going from one layer 2 to another layer 2, the MAC address header, right, will be rewrite, right? Now the source become this port's MAC address, and the destination will be this router's port MAC address. Okay. Then layer 3. See the layer 3 from coming in and going out, it didn't change, right? Still keep the same, because this packet is eventually going to get to 10.10, right? So along the path, this header won't be rewrite or won't change. It's just following this destination IP, the router will route the packet towards the destination. Okay, let's move forward, right? Also, the router only see up to layer 3. Okay, and it moved to the other router, right? The other router, okay? This is a DNS server here, okay? Let's open this up and see. Layer 3 no change, right? Only forward, right? Layer 2. Layer 2 is from here is this, and when it's going out from this port, it's going to change, right? Change the source MAC and destination MAC. Source MAC is this port MAC, destination MAC is this server's MAC, okay? And then let's move forward. Okay, so the server received this query message, right? Let's open this up. Look at this. You can see the layer 7 DNS application layer. Now you can see that, right? Because the server is working on an application layer, right? Also, you can see all these layer 2, 3, 4, right? That's the incoming message. Obviously, the source port it didn't change from the PC here, and destination port it didn't change, right? But its target destination port 53, which is the DNS service, okay? And source IP, destination IP didn't change. Source MAC, destination MAC. Source MAC it will be this port's MAC address. Destination MAC will be this MAC address, okay? Then the outgoing message means the DNS server will return this query, right, to the PC, right? Then everything is switched, like the source port switched to 53, and destination port switched to this, the previous source port, right? Everything is switched. See that? Source IP, destination IP switched, source MAC, destination MAC switched, and we'll send it out. Let's move forward. Send it back to this router, right? Okay, let's take a look. You know, the router only checked layer 3, okay, and replace the layer 2 hop by hop, right? It's doing that actually, okay? This router, see that? Only check layer 3, right? But rewrite layer 2 every hop, okay? And to the switch, and the switch only check up to layer 2. Okay, see, no layer 3 information because the switch function in layer 2. Okay, and then eventually it get back to the PC. Okay, now you can see because the PC received, see that PC receive the response from the DNS server, right? And then the PC will get the google.com's IP. Then if we move forward, because we type in google.com, right? Then see, now it didn't show up anything yet, right? Because the message, the first message you sent towards Google, it need to resolve the Google's IP address, so that in the background, the PC is trying to resolve the Google's IP through a DNS query, right? This action already finished. Then next packet will be google.com, towards google.com. Let's see, okay? Move forward. See that a new message coming out, okay? This message, you can see destination port is 80 now. 80 means what? Means HTTP protocol, right? The server is listening on port 80, right? HTTP is a web server, web browser protocol, right? So the server is listening on port 80, and the TCP source port is the same. It's a randomly assigned port by the PC when it's try to connect to the server. Okay, and then remember it was destination IP was google.com, right? Because it resolved from the DNS server. Now you have got the IP, you can wrap your layer 3 header, right? Then the source MAC and destination MAC will still be the router's this port MAC address, right? This message will be forwarded onto the switch. Look at the switch. Still layer 2, only check layer 2, right? Same as the DNS query, right? Still on the router, okay? On the router, you open it up. Router will check layer 3, up to layer 3, right? Based on destination IP, router will decide which port is moving out, right? And on this router, you can see same, right? Check layer 3 header and replace layer 2 header every hop, okay? Now it is move on this switch, right? This is a switch only check layer 2, right? Based on layer 2 source MAC, destination MAC, and forward the packet, okay? Now it reach to Google server. Okay, now you can see this is HTTP service, right? It's network browser, right? And coming in that with port 80, because the server is listening on port 80 and it know, okay, it is towards my HTTP application, right? If the destination port is another port, it's not going to be terminated on the HTTP service, right? And source IP, destination IP, source MAC, destination MAC is already changed by the router, and this is a return message, right? When you browse Google, right, Google will return you, response you, right? And the source port and destination port switched, source IP, destination IP switched, MAC address is also switched. Then the Google server will return the message to the PC. Let's take a look at the PC, right? See, nothing pop up yet, right? Until the Google server return that message, this will pop up, the main page will pop up. Okay, let's move forward. See the message response coming back, right? We don't check it anymore, it's same, right? Router only check layer 3, and switch only check layer 2. Router will rewrite layer 2, right? Okay, then return to the PC. As you can see, this is the whole message, return to the PC, and then no going out. This process finished. Let's take a look at what happened. Here, see that Google, this is a simulator, right? Google main page coming out. See that? If I open another, a layer, it will start again. start another DNS query again. Okay, that's it. I think that's for today. Later on I'm going to talk about other protocols. We are gonna simulate other protocol like SSH, FTP, but it is for today. Please subscribe if you like. Thank you very much.